Now we are going to shift our focus to a different OAuth scenario: machine-to-machine authentication, sometimes referred to as server-to-server OAuth. In this model, there's no user interaction involved. Instead, we'll demonstrate how one service or backend system can securely request access to another by using OAuth2 credentials. This is particularly useful when we want to protect API endpoints and ensure that only authorized systems, not users, can call them. Our demo scenario involves two Spring applications. Let's first understand key configuration properties required for OAuth authentication. Let me open application properties of my second Spring Boot application. Each OAuth configuration includes several important properties. Client ID. This identifies our application uniquely to the Auth0 provider. Client secret. This secret ensures secure authentication. Protect this confidentially. Audience defines the intended target API, indicating to Auth0 what the token is for. We configured the audience in the previous lesson when we configured identity provider. Token URL. The URL provided by Auth0 to retrieve the OAuth token. Grant type specifies OAuth flow type. Here it is client credentials suitable for machine-to-machine interactions. Now let's dive into our example controller, OAuth demo controller. This controller demonstrates OAuth in action. The OAuth properties are injected via value annotation. A REST template, defined as a Spring Bean in Spring Demo 2 application class, will facilitate HTTP requests. Upon hitting this endpoint, the method performs several steps clearly. Token request preparation. Headers and body parameters are prepared to request an access token. Fetching the access token. It posts this request to Auth0's token URL, receiving an access token in return. Calling the protected API. Using the retrieved token as bearer authentication, it accesses our secured payments endpoint. Returning API response. Finally, the response from payments is returned directly to the client. Note the internal class token response, simplifying parsing JSON response containing the token. Feel free to press pause and explore this code one more time. Just a reminder that you can find all source code examples in attachments to the lesson. And in case you will have any questions, or in case something still remains unclear, please ask your questions in comments below the video and I will be happy to answer. At the meantime, let's proceed from the client application to the server application, the one that will handle requests and contains protected API. Shifting focus to our second application. Do you remember that we included OAuth client starter? That starter automatically securing endpoints with Auth0 login forms, which is not what we want for machine-to-machine communication. So, if we need public endpoints not protected by login form, we must customize the security filter chain bean. I opened configuration file where I implemented security filter chain bean. So let us now take a closer look at this configuration and, more specifically, why we have two separate security filter chain beans. At first glance, one might wonder, why not use a single configuration for all endpoints? The answer lies in the very architecture of Spring Security and how it handles different authentication mechanisms. In our case, we are trying to achieve two distinct modes of access within the same application. On one hand, we have endpoints like payments and debug, which are intended to be accessed by another machine, such as another backend service, using machine-to-machine authentication with a JWT token. On the other hand, the rest of the application is designed for interactive use by humans, where users are redirected to an Auth0 login page. That's the standard OAuth2 login flow. Now, Spring Security doesn't allow us to configure both OAuth2 resource server and OAuth2 login in a single security filter chain, because these two flows are fundamentally different. One is token-based and stateless, while the other involves sessions, redirections, and user interaction. To support both flows side by side, we split our security configuration into two beans. Each bean is responsible for a specific slice of URL paths. The first bean, marked with order 1 annotation, targets only payments and debug. It uses a JWT-based resource server configuration, meaning it expects a valid bearer token in the authorization header. This is exactly what we need for service-to-service calls. The second bean, with OAuth2 annotation, is a catch-all for everything else. It enables interactive login using OAuth2 login, which triggers a redirect to Auth0's hosted login page when a user tries to access a protected resource. The order annotation is critical here. It ensures Spring processes the filter chains in the correct sequence. The first matching security filter chain is the one that applies. So, requests to payments will be handled by the JWT-based chain, while all others fall through to the second one. This pattern is a powerful way to support hybrid security models, where an application is accessed both by users and by other systems. It keeps the authentication mechanisms cleanly separated while still living within a single Spring Boot application. Let's check which application properties we need to add in our server application in order to process requests properly. To be honest, not all of these properties are mandatory if you rely on default values and default configurations, but I decided to keep them here on purpose to show you all the flexibility of the configuration. We begin with the JWK-set URI property. This URI points to what's called the JSON Web Key Set, or JWKS endpoint. It's a publicly accessible endpoint that returns the public keys used by the authorization server to sign JWTs. In our case, that's Auth0. Why do we need this? Because when our resource server receives a token, it needs to verify the signature to make sure that the token is authentic and hasn't been tampered with. It doesn't make sense to ship the public key manually or hardcode it, especially since key rotation is common in production environments. Instead, Spring can fetch the key dynamically from this URI and use it to verify the digital signature of incoming JWTs. This is fundamental to trust. Next, we see the authority prefix property, and you'll notice it's intentionally left empty. By default, Spring Security adds a prefix, scope underscore, to all authorities extracted from the token. By setting the prefix to an empty string, we avoid having to rewrite or remap scopes, like read payments, into scope underscore read payments, and we let the scopes flow directly into Spring Security's authority system as is. Now let's move to the principal claim name property. Here we've defined sub as the principal claim. This aligns with the JWT specification, RFC 7519, which defines the sub-subject claim as the standard way to identify the entity, the user or client, that the token represents. In a machine-to-machine flow, this might be a client ID. In a user-authenticated flow, it would be the user's unique identifier. And finally, we have the authority's claim name, which we've set to scope. This raises an interesting point. While scope is commonly used in OAuth2, it's not part of the JWT standard itself, but rather a convention defined in the OAuth2 specification. When a token is issued, the scope claim usually contains a space-separated string listing the permissions granted, such as read payments, write payments. Spring can then map these scopes into granted authority objects, which we can use in our application to authorize access to endpoints. So when you look at these four properties together, what you're configuring is a chain of trust and interpretation. How the server should validate the token via the JWKS URI, how it should extract identity, sub, and how it should translate the scopes into authorities while deliberately suppressing unwanted prefixes that might interfere with your access control logic. This configuration is both minimal and powerful, and it reflects a deep alignment with the standards that underpin modern OAuth and JWT-based security. I used term claim. Let me elaborate on that and explain what it is. JWT tokens contain claims, key value pairs conveying user permissions or roles. A claim is essentially data mapped within the JWT. For example, a permission like read payments might be provided as a claim. Even in case some question remains, please post your question in comments below this video. Now, let's review the source code of Payments Controller class. This is exactly the class that contains protected API. Let's review and learn how we protect the API. This example gives us a practical demonstration of method-level security in a Spring Boot application. The class is annotated with REST controller annotation, which, as you know, is a shortcut for controller and response body annotations combined. It tells Spring that this class will handle web requests and return data directly in the HTTP response body, typically in JSON format. Within this class, we have two endpoints. The first one is payments, annotated with get mapping annotation to handle get requests. But more importantly, it's protected by pre-authorized annotation that checks read payments permission. Now, what does this mean? The pre-authorized annotation comes from Spring Security. It tells Spring to evaluate an expression before the method executes. In this case, the method is only accessible if the caller has an authority, essentially a permission or role, named read payments. The term authority is a string claim in the JWT token, typically found under the scope or permissions fields, depending on your identity provider configuration. Instead of has authority, we could use other expressions here, such as has role admin, has any authority read payments, write payments, or even Spring expression language like authentication.name, =$, and some email. This makes pre-authorize a very flexible tool for fine-grained security control. Now, the second endpoint is debug. It's not protected, which means it's accessible without any permission checks. It accepts a parameter of type authentication. Here's the important part. Spring automatically injects this object at runtime. If the request is authenticated, meaning the user has a valid token, Spring will build the authentication object from that token and provide it to the controller method. Inside this method, we extract all authorities granted to the authenticated user, map them to their string values using getAuthority method reference, and return them as a list. This endpoint is especially useful for debugging your token configuration to see what permissions are actually present. And remember, for pre-authorized to work, the application must have enabled method security enabled in its configuration. Let me open my configuration class. And here you can see that I added this annotation to the class. Without that, Spring will ignore pre-authorized annotations entirely. To proceed with the demo, make sure that you started the Spring Demo 2 project, and when it is up and running, we are ready to proceed. It looks like now we are ready to see end-to-end flow of machine-to-machine OAuth implementation. Everything is configured. Let me open web browser. My second application is also deployed on my laptop, but accessed via another port. So in the address line, I type localhost 8081 / and then I write resource name, demo machine to machine. So on the background, my app managed to get token, send request, another service managed to authorize the request, check the permission, and print into the response body transactions. And if I disable read payments permission in API in my identity provider, then I should get in response 403 status, which means forbidden. As you can see, this proves that my API endpoint is protected and only users with proper JWT token and permission can access it. That's all what I planned to discuss with you in this lesson. Let's recap what we've learned today. We started by setting up a Spring Boot project and explored its structure. You learned how to add and configure OAuth2 dependencies for both client and resource server scenarios. We discussed the purpose of key Spring Boot starters, OAuth2 client, and OAuth2 resource server. I demonstrated the OpenID Connect client flow and how login and logout work with an identity provider. We explored how to implement and test the machine-to-machine flow using client credentials. You saw how to configure the OAuth server and align it with Spring security expectations. Finally, we reviewed the most important Spring Boot properties related to OAuth2 and how to adjust them. That's all for this lesson. Thank you so much for your attention. Have a great day and see you in the next lesson.